Stock closing price prediction using deep learning models. The presentation is brought to you by Akshada Joshi, Anita Ganapati, Archana Krishnamurthy. This is a part of a project presentation for the course Deep Learning Systems, which we took in the fall of 2021. Introduction about the project. Using time series data analysis for stock price forecasting is a complex and a challenging because many factors can influence stock prices. Such factors can be analyzed over time for the stock price prediction. Machine learning and deep learning have been shown to obtain a better forecast for stock prices than the traditional approaches. So this is what we have tried to do in this project. And for this, we have used various models, example, LSTM and ARIMA. So the main project goal is stock price prediction using financial data, sentiment data, Google Trends, and the COVID data, along with improving the prediction accuracy by adopting different deep learning models. The contribution that we have added to the paper that we have tried is use different sets of features to show the variations in the prediction loss. And we have tried to compare the different models' performance and as well improve the performance by using hybrid models. So the problem statement in the paper is, the paper that we have chosen is stock closing price prediction using deep learning models. So we are trying to predict the closing price of a stock using different deep learning models. In the presentation, the different sets of models that we have used are the LSTM, GAN, GRU, and the hybrid LSTM along with ARIMA. So the main data source that we have tried to experiment in this project is the Apple Inc. data that we have obtained from Yahoo Finance, which is very high level. And we have used all the financial features, along with the sentiment data extracted from Reddit and the COVID data along with Google Trends.
So here is a flowchart which we have used for our project. You can see the different classifications of the data set, and the data set has been split into train and test, and different models have been used for training and testing for the prediction purpose. So talking about the LSTM model, that is the first model which was used. And this is a memory line model, and it has proved to be very useful when forecasting time series data. And the memorization of the earlier stages in this model is performed through gates. And the model architecture will be explained on the later slides. But right now, moving on to the next model, which is the GRU model. So the GRU model is an alternative solution to RNN, and it stands for Gated Recurrent Units Network model. It is very similar to LSTM model, but it is highly optimized, and the number of parameters to estimate is also less. Then talking about the GAN model, GANs are a very clever way of training a generative model by framing the problem as an unsupervised learning model problem with two submodels. That is the generative model, which trains to generate new examples, and then we have the discriminative model, which will classify the examples as real and fake.
The hybrid ARIMA LSTM model is an adaptation of the stock price prediction based on the ARIMA RNN combined model created by Shui Ling, Yu, and Zeli. This model follows the same structure as the model proposed in the paper. The hybrid LSTM model is open to a variety of experimentation. This model proposes to overcome the challenge with the volatility of stock data and the problem with regards to overfitting from a neural network.
Talking about the overview of the features which we have used in this project, there are all these different categories of the features, and I would be talking about them later, but we have the original financial data, we have the technical indicators, Fourier transformation, sentiment analysis, COVID data, and Google Trend. Moving on to the next slide. This is just a variation of the closing price for Apple from 2017 to 2021. So this is the sentiment analysis. In this, we have calculated the bullish and the bearish scores for each day, and the source is Reddit, and the data is pulled from July of 2017 to December of 2021. Then moving on. And this is the Fourier transformation of the bullish and bearish scores. The blue plots are the original values, and then the green plots show the Fourier transformed features. And it is quite clear that they are very smooth as compared to the original data. Then the COVID data, it is extracted from the data repository at Johns Hopkins, and the date range is from Jan of 2020 to December of 2021. And the features which are extracted are the change in the number of cases and the number of deaths. And finally, we have the Google Trend data, and it is extracted from Apify, and it basically tells the number of times the keyword AAPL was searched on Google worldwide. The final data set is a combination of all the features which I talked about before, and the date range comes out to be from July of 2017 to November of 2021. The goal of the project is to predict the closing price on the fourth day, given the data on the first 3 days. The data has been normalized using min-max scaler to bring it in the same range from 0 to 1. And we have the X-train, Y-train, X-test, and Y-test data frames finally, and these are the sizes of the data frames. Moving on to the prediction and the plots. So the first model is the LSTM model. In this, there was a bidirectional LSTM layer used along with 2 dense layers, and the architecture parameters have been given on the right hand side of the model architecture. And these are the plots. The first plot has the full data set, and the rest of the plots are with varying features. And it is quite clear that the one with the Google Trends data that has the highest accuracy, and the predicted and the real closing price match. Then is the GRU model. Here we have used 2 GRU layers and 2 dense layers, and the model parameters are given on the right. And these are the plots for GRU model. The model tends to deviate a little as we go towards the end of 2021, but still it has performed pretty well, especially for the full data set. Then we have the GAN model. Here is a flowchart of how the GAN model works in our project. We have got the generator and the discriminator models. And in the GAN model, for the generator model, we have used 3 GRU layers and 3 dense layers. And for the discriminator, we have used 3 CNN layers and 3 dense layers. And the next slide will show the plots. And it is pretty clear that GAN model is performing very well as compared to the rest of the models. And the difference between the real and the predicted closing price is very low for GAN model.
For the LSTM hybrid ARIMA model, multiple experiments with various moving averages, such as exponential moving average, triple exponential moving average, triangular moving average, the Kaufman adapter moving average, and various others were tried. And among these multiple architectures that were introduced, the TIMA and the midpoint moving average stood out. Now, the RNN LSTM were implemented along with exogenous variables introduced to generate a multivariate ARIMA forecast, which means that we had a look back of about 3 days and a forecast of 1 day. Now, the combinations of features introduced into this model were Google Trends, COVID death rate, sentiment scores, as well as the complete data set. The moving averages are introduced for a smoothened distribution over time and were determined by the kurtosis for a sample of about 100 days. The data was split between high volatility and low volatility time series based on the moving averages that were determined. These are some of the results that were performed for each of the experiments. We can see that the GRU, LSTM, GAN, as well as hybrid ARIMA, TIMA, and midpoint have been listed out. Out of these, GAN performed quite well on some of the experiments, and hybrid ARIMA performed well for TIMA as well as midpoint for one of the 2 experiments. Some of the additional experiments performed for hybrid LSTM ARIMA for the different moving averages are listed here. In conclusion, the dataset changes are were considerable, and the error produced by each of the models were completely different. Some of the errors were even 60% increase in terms of the RMSE. For the full data set, hybrid ARIMA with TIMA moving average had the lowest RMSE of about 3.09. For rest of the data sets, GAN model performed well with the least RMSE. Non-traditional models, namely the LSTM and GAN, are an improvement over the traditional models such as GRU and LSTM. Now, in terms of future enhancements, some of the things that we could do is develop the sentiment analysis course and work with additional sources such as the Bloomberg Business Week as well as TechCrunch. Another improvement can be done to the GAN model by using different losses using the WGAN as listed here. These are some of the references that we used. Thank you for taking the time to listen to us.